All right, everyone. In our journey through business administration, we spend a lot of time talking about the big ideas: strategy, market feel, intuition, and those are all incredibly important. But today, we're going to roll up our sleeves and get into the hard science that makes the art of business possible. We're going to explore one of the most powerful tools you'll ever use: the calculus of optimization. Now, I know what you're thinking. Calculus? But trust me, this isn't just about abstract math. This is the engine that can find, with pinpoint accuracy, a company's maximum possible profit. So let's get started. So this is it. This is the multi-million, sometimes multi-billion-dollar question that every single person in business has to face, whether you're launching a startup from your garage or you're the CEO of a global corporation. If you produce too little, you're just leaving cash on the table. Customers want your product, but you can't supply it. But if you produce too much, oh, you get buried, absolutely crushed by warehousing costs, by waste, by having to slash prices just to move inventory. So how in the world do you find that perfect razor-thin sweet spot? You know, for the longest time, business leaders had to rely on gut feelings, on experience, on a bit of guesswork. But in today's world, that's just not good enough. The competition is too fierce. The margins are too tight. The real answer, the precise one, lies in a core concept from calculus. It's all about understanding, measuring, and then acting on the rate of change. We're going to see how math gives us a crystal clear, data-driven roadmap to solve this critical business puzzle. Okay, let's give this challenge a formal name. We'll call it the production puzzle. And it really is a puzzle. It's this universal balancing act. See, the goal isn't just to be profitable. Anyone can do that. The goal is to squeeze out every last possible cent of profit. To find that one single level of output that makes you the most money, that right there is the very definition of optimizing your operations. Now, here's where it gets really interesting, because this relationship isn't fixed. Every single time you produce one more item, just one, two numbers on your spreadsheet change. Your costs go up and your revenue goes up. In economics, we have special names for this. The cost to make just one more unit, that's your marginal cost. The revenue you get from selling that one more unit, that's your marginal revenue. And the key thing to understand is that these numbers are always in flux. The cost to make your very first widget is totally different from the cost to make your 10,000th. And that's the dynamic we need to analyze. So, if costs and revenues are constantly shifting, how on earth can we track them with any kind of precision? It feels like trying to hit a moving target, right? Well, what we need is a tool that can take a snapshot of change at a single, precise moment in time. And in the world of mathematics, that amazing tool is called the derivative. So let's really break down what this thing is and how it works. Okay, here's the textbook definition. But I want you to laser focus on two words here: rate and instantaneous. A derivative doesn't just tell us that your costs are going up, it tells you how fast they're going up. And it's not giving you an average over the last quarter or even the last week. No, it's telling you the rate of change for this exact moment. For the very next unit that comes off your assembly line, what will be the exact, to the penny, change in your total cost? And what will be the exact change in revenue? The derivative is what gives us that number. To really make this click, think about driving a car. Let's say you drive 60 miles and it takes you exactly 1 hour. Your average speed was 60 miles per hour. That's a nice summary of the trip. But it's not very useful for making real-time decisions, is it? The derivative, that's your speedometer. The moment you glance down, it tells you your instantaneous speed: 55, 62, 70. It's that speedometer, not your average speed, that tells you whether you need to hit the brakes or tap the gas right now. And that analogy brings us right back to business. This is a perfect illustration. A derivative is basically a speedometer for your money. When you take the derivative of your cost function, you get your marginal cost, a speedometer telling you exactly how fast your costs are accelerating. Take the derivative of your revenue function, you get your marginal revenue, a speedometer for your income. These tools tell you exactly what's happening at the margin, with the very next unit you produce, which is where all the most important decisions are made. Now, let's pause and talk about a few common traps I see students fall into here. First, never confuse the average with the instantaneous. Your average profit across all units might look great, say $10 per unit. But if the derivative, your marginal profit, tells you that making the next unit will actually cost you 50 cents, then you have to stop. Making another one is just bad business. Second, these rates are almost never a straight line. They curve. At first, your marginal cost might go down because of economies of scale. But then you hit capacity, you have to pay overtime, and suddenly your marginal cost starts to skyrocket.
That's why we need calculus to track that curve. And finally, this is a big one. Just because your revenue is growing doesn't mean you're doing well. If your revenue is growing, but your costs are growing even faster, then your profit is actually shrinking. The derivative lets us compare the speed of both.
Okay, so the theory is in place. We've got our tool, the derivative. We understand what it measures, that instantaneous rate of change. So now let's actually apply it to the two most critical functions in this whole discussion, your cost function and your revenue function. Let's start with the cost function, which we write as C of X. This is just a mathematical equation that represents your total expenses for producing X number of units. Imagine you're running a t-shirt company. You've got fixed costs, right? The rent on your workshop, the lease on your printing press. You pay those whether you make 1 shirt or 1,000. Then you've got variable costs, like the blank t-shirts, the ink, the electricity. The more you print, the more those costs go up. C of X is the function that captures that entire relationship.
And on the other side of the ledger, you have the revenue function, R of X. This models all the money coming in. Now, you might think, oh, that's easy. It's just the price per shirt times the number of shirts I sell. But is the price always the same? Absolutely not. To sell 100 shirts, you might get $20 each. But to sell 10,000 shirts, you'll probably have to offer a bulk discount, lowering your price per shirt. The market can only absorb so much at a certain price. So your revenue curve isn't a straight line. It bends. And R of X is what models that real-world behavior.
So with those two functions, we can lay out a clear 4-step playbook. Step 1, you gather all your business data, your receipts, your sales figures, and you build your CX and RX functions. Step 2, you differentiate. You apply a calculus to find the derivative of each one. That gives you two new functions, C prime of X, which we now know is the marginal cost, and R prime of X, the marginal revenue. These are your financial speedometers. And then steps 3 and 4 are where the magic happens. That's the analysis, where we compare those two speedometers to find the goal.
And this brings us to the absolute climax of our analysis. This is the whole point of the exercise. We have the rate of change for our costs, and we have the rate of change for our revenue. By laying these two functions on top of each other, we can find the exact production number where our profit hits its absolute maximum.
You know, the source material we're working from today really nails it with this quote. This is key to understanding the relationship between output and profitability. This isn't just a math trick to find a number. This is about gaining a deep, fundamental understanding of how your production decisions directly create or destroy profit on a unit-by-unit basis.
And here it is. This is the single most important sentence of this entire discussion, so let it sink in. Your total profit is maximized at the exact production level X, where your marginal cost equals your marginal revenue. In mathematical terms, that's where C prime of X equals R prime of X. Just think about what that means. It's the exact point where the money you spend to make one more t-shirt is perfectly equal to the money you get from selling that one more t-shirt. If you make even one more shirt past that point, the cost of making it will be higher than the revenue it brings in. You will literally be paying to lose money on every single unit you make from that point forward. That intersection, that's your mathematically perfect place to stop.
So let's really solidify this key takeaway. The incredible power of using calculus in business is that it forges a direct, unbreakable, and quantifiable link between a decision you make on the factory floor and the final number on your profit and loss statement.
So why is this so important for your careers? Because this approach elevates you from a manager who operates on gut feeling to a leader who makes decisions based on data and science. You'll be able to walk into a boardroom and say, I don't think we should make about 8,000 units. I know, based on our cost and revenue models, that our optimal production run is exactly 8,452 units. Any more or any less will reduce our total profit. And think about the power for planning. What happens if our supplier raises the price of cotton by 5%? No problem. We just adjust our CX function, recalculate, and we'll have our new optimal production number in minutes. That is real strategic power.
And that brings me to my final thought for you today. We've used this incredibly powerful tool, the derivative, to solve for the optimal production quantity, X. But the exact same logic, the very same mathematical framework, can be used to optimize almost any variable in a business. What's the perfect price to charge for your product? What's the optimal amount to spend on your marketing campaign? How many staff should you have on a shift for maximum efficiency? The calculus of optimization gives you the framework to answer all of those questions, and that is the power I want you to take with you from our discussion today.